Okay, we should start discussing. We'll close all these topics in today's session. Map function, filter function, and reduce function. All this we are going to talk in today's session. Okay, so let's talk about this. What is it? This lambda function or anonymous function? What is anonymous function or what is lambda? So this concept is there not only in Python. These are all there even in Java. I believe even in C sharp, in all these languages, this lambda function is very much familiar and popular, friends. So, and we call these as anonymous functions because usually we know a function has a name, but these anonymous functions don't have a name. A function without any name is anonymous function or lambda function. And the purpose of these anonymous functions is for an instant use. If you want to if you want to just use somewhere an instant code, if you want to create an instant code just in a line or two, that's all. If you are writing lengthy code means then we can use normal functions, regular functions. But if you want to just create a short and simple functions, then lambda functions are very much useful for us. And usually these lambda functions we can just create in just a line or two. That's all. Like in C++, there is something called inline functions. So this is something similar to that, but much more simplified and more powerful. So that is the simple idea, friends. So what is it here? Anonymous function means it's something without any name. And generally, if you want to just create a code just in a line or two, these anonymous functions are very much useful. And if you want to just create an instant code, even in such cases, anonymous functions are very useful to us. So, and lambda functions we use are nothing but such functions. Lambda functions are nothing but anonymous functions, and they don't have any name. And we create this lambda functions by using a keyword lambda itself. So for to create lambda functions or anonymous functions, we create such functions by using a keyword. What is that keyword here, friends? Lambda. And the syntax look like this. This is the syntax, friends. This is an example. You can consider as an example or a syntax. This is the syntax otherwise. What is this? That lambda keyword first, and then the parameter list, whichever you want to pass, and then your expression or logic. So this is a simple syntax to create a lambda function. I hope you are following, friends. Right? So what is it here? So the syntax is simple. A lambda keyword with next after that arguments list followed by colon and then your logic. So this is so simple. We'll see few examples to understand how simple lambda function is. We'll try to, in today's session, we'll try to implement few use cases to understand this lambda functions. I hope that is clear, right? So this is a simple idea. What is anonymous? What is lambda? And in which situation we should prefer lambda functions and where this is popular. Lambda functions are very much popular. So suppose if you go to PySpark, some data, this big data related technology, most of those, even there are certain methods like map function, reduce function, or many more like that. In every of these, in all these functions, they try to prefer to use this lambda functions, and this is one of the most popular construct in Python. Okay, so that is fine. Let's understand now how to. What is the advantage with lambda? How simple is lambda? Let us try to understand that. Now you see, let us create a simple program, sum of two numbers without lambda first. And we rewrite the same program with lambda and see how simple it is. If you see here, this is a normal function, a parameterized function, just finding sum of two numbers. This is the code of function here. And we are trying to, what we are trying to do? we are trying to call that function. So here, if you want to find sum of two numbers, at least we are writing some 4 to 5 lines of code. But if the same thing, you don't need to understand anything about Lambda, and we are just trying to understand how simple it is to use Lambda. That's all, friends. So you can see here, if it is a Lambda function, this whole code, which we wrote in some 4 or 5 lines of code, that is just written in just one line of code. And that's how lambdas are. That's simplified lambdas are. You got it right. Whenever you want to write some small short codes, right? In such cases, lambda is most used anonymous function. Now, this is the quick difference. If you want to see the difference between a regular function and a lambda function, so you can see the code, two different code snippets are in front of your eyes, friends. And by looking at those code bases, you can easily understand if it is normal function or a regular function, at least we need some 3 or 4 lines of code. But if it is lambda, we can implement same code in just one line. So that is the difference. So, but of course, not every time we cannot create lambdas. Not every time we need to use regular functions. Only when you think that that code fits in a single line, then we need to prefer to implement lambda. And there are many cases where we need multiple lines of code. In such cases, we need to go and implement regular functions. Even if you have lambda, it doesn't mean that everything can be implemented with lambda. I hope this is clear, friends. Okay, let's quickly test these two code snippets and just understand the behavior of these two. I mean, how the difference of these two functions like regular and lambda. So what do you do here, friends? I'm just using this. This already we are familiar. So let's open our Python and then what we do. So where is it? Functions topic. Again in this, let's add new Python and then lambda functions. Excuse me, friends. And then we don't need all this. It's a little bit disturbing. So open lambda functions and then first let's quickly get an idea about a normal function and see. This is something which we are familiar. So, and we are not new to this. Maybe it's here because we are just printing it directly by passing this method called to the print statement. If you want, you can copy this result, assign this color to some variable and print it. Else, you can directly print like this as well. But we have to pass a function to a print function, to a print statement, only when that function is returning a value. So keep this in mind, friends. When can we pass a caller to a print statement directly? We can pass a caller to a print only if that function is returning a value. Else it returns none, and we don't have any big benefit out of it. I hope that is clear. Right, friends? So, of course, in this case, this is a quick test. We are just creating a simple function to find sum of two numbers. And then we are calling that function and printing. This is a regular function. Let me just add comment. And we are all familiar with functions now. Okay, regular function. And then save this and then run this and then run and see the output. You can see we got 30 because we are passing 10 and 20 through color here. This is case 1 with regular functions. Okay. There is a case 2. This is our case 2 here. Our case 2 is lambda functions. So what is lambda? Lambdas are anonymous functions, a function without any name. So by now you should be familiar. And what is the use of lambda? If you want to just implement a program or a code in a single line or two, lambdas are most recommended for anonymous functions. And also sometimes we need to pass a function as parameter to another function. Even in such cases, lambdas are very much useful. Okay, so let's see how can we rewrite this code. Simple. You can just use, what is that, you can just write like this, some lambda space to find sum of two numbers. What are the parameters you are passing to this regular function? You just copy those two and pass it in the first place here, because as per syntax, we should start with keyword lambda, and then this next comes is we can consider this into three parts. The first part is the keyword, second part arguments, okay, and third part colon. So it is logic, and we are done with lambda function. So that's all. So this is how we should create a lambda, and make sure you assign it to some variable, okay, some add equal to. So that's all, friends. This is how we create a simple lambda function. Now what do? We should call this lambda through this variable to which we are assigning this function. So now we created lambda and assign that whole function to some variable here, right? I'm just seeing there is some error. This error is coming, everything is fine. Okay, we'll run and see if it is not working, then we'll see it on that. Okay, this is a simple code to create lambda function. That's all, friends. How many parts are there in lambda functions? Three parts. The keyword, and second part is arguments, and the third part is logic. So in this way, we can break down this syntax of lambda function into three parts. That is fine. And once we create a lambda function, we should assign it to some dummy variable. So that is very important. So we have assigned that lambda to some variable. This acts as a reference to the lambda, to this function lambda, which is an anonymous function. Now, how do you call this lambda? We cannot call it directly because it doesn't have any name. So we use this name or reference that is pointing to this lambda function. How do you call it? We should call add, and we should call this variable add. And this add acts as a caller, even though that is not the actual function, but this add, whatever the variable we declared here at line 9, this acts as a caller. So now use this variable add and just use this and pass parameters to this lambda function. How many parameters we should pass to lambda function? We should pass two parameters, which is a and b. Parameters in sense two values we should pass to these two parameters, right? So here pass two values, some 10, 20. You can give any value. It's not like it should be 10 and 20. Pass anything of your choice. And this is clear. So this is a simple lambda function. You can see here the difference. We have two different types of code bases or code snippets here. One belongs to regular and the other one belongs to lambda. By looking at these two code bases, you can easily see the difference. So regular functions generally we need to implement in little lengthy code. But lambda, usually lambdas are implemented just in a line. But not every time we can use, we should use lambda. Not all the cases doesn't demand lambda. There are certain cases where we need just an instant code. In such cases, we prefer lambda, but in majority of the cases, we prefer regular functions. Right, okay, anyhow, that is clearly discussed. I don't want to go for more repetitions, but this is the idea. Shall we run and see the output? Already we ran this and see the output. We are very familiar with this kind of regular functions. But lambda is something new to us. Let's run this now. Indentation error. Okay, that is fine. Just make it to the start of the start of the editor. Now this error will be removed. Let's run this now. Now we can see, I think, of course, we are doing calling of lambda, but we are not printing it. So either assign this result to some variable, some result equal to something, and then print that. What does it print? So, and you can simply say the result is, and some flower braces dot format of, you can just pass result here. So this is how you can print the result written by a lambda function. Now run this. Now you can see here, this is coming from a regular function. This is coming from lambda function. I hope this is clear. So this is a quick difference between a regular function and a lambda function. And we can explore this lambda. There are many more examples available in different websites. We can Google it. Stack Overflow is one of the best area where we can find many examples for lambda. You can try to explore there. But this is the idea how to create lambda functions. And we don't need to worry about it. If you want to create any kind of lambda, we have, there is a lot of, there are different kinds of samples available. So we can Google it and get it. So that is the simple idea. I hope this is clear for all of you friends, right? So this is the idea about lambda functions. This is another example, scenario 2. This is nothing but finding greatest of two numbers with lambda. If you want, we can quickly test this. There is nothing in this. The same thing where what we find greatest of two numbers, you can see here. This is case 3, maybe you can consider it as case 3. A simple example of lambda, you can see here. So what is it? Again, this has 3 different parts. The first one starts with lambda keyword, second one with arguments, third one with what is it, friends? Your logic or expression. And what is this code lambda doing here? This is finding greatest of two numbers. The same thing we can implement with the regular function, but here we are implementing that with lambda in just a line of code. Now, how we are doing here? Lambda keyword as usual. This should come first. And later on, what is that? Variables, arguments as seconds in the second place. As we are finding greatest of two numbers, we need to pass 2 parameters here. And then the logic. So we are printing A first and then applying what is it? Print A if A greater than B. Else print B. That is what we are seeing. I mean return B. And we should not say print A or B. Return A if A greater than B. Else return B. That is the meaning of this logic. I mean this code base. Okay. Is that clear, friends? Sorry. So that's the idea, friends, about what is it, lambda functions and finding greatest of two numbers using lambda. Clear, friends? So now let's run this, see what would be the output here among 120. We know 100 is bigger than 20, then we get the output as 100 itself. Okay. Now run this now. You can see here we got among these two 120, 100 is bigger, and that is returned by the lambda function. So this is a simple use case with lambda, how to find greatest of two numbers. So this is an idea, friends. I hope this is clear for all of you. So that's all, friends. That's idea about lambda functions. Maybe if you want, you can try this example as well. What is it? This is greatest of three numbers, I believe. And here you can see we are just taking lambda. You can see in the first place and 3 parameters this time. And then we are just following the process. What is it? Print A if A is greater than B and C. Else print B when if A is greater than B. Else print C. So whatever we implement in the regular function, here also we implement the same, but the difference is here we don't implement code in multiple lines, but whatever we need to implement, all that has to be implemented in a single line here. And that's how we create Lambda functions. I hope this is clear to all of you friends. Now what's happening in Lambda functions, whatever the result we get here, that is returned and assigned to this variable x internally. And this x is nothing but it's like a reference which is pointing to this Lambda function. And you know very well, in Python, everything is an object. Even functions are objects. So that's why Python is, we can call it as a pure object oriented program, more than Java or more than anything else. In Python, everything is an object, including data types. But in other traditional languages like C, C++, Java, or C Sharp, still data types are primitives, not any objects. So the idea. Okay, I don't want to stay here for a long time on Lambda. Would like to jump on map, reduce, and filter. I would like to complete all this in today's session because these are all important things. Do you want me to test this code as well, friends? This is a simple one again. What we can do. Let me quickly test this and show you. So this is use case 4. And what we are doing here, just simply finding greatest of 3 numbers using Lambda. What we are doing again, this Lambda function is broke down into 3 parts. Your Lambda keyword and the argument or parameters list and your expression at the end. Okay, so let's see this now. So how this works here? This parameters 3 nothing but accepts 3 values and then print a if a greater than b and a greater than c. That is scenario 1. If these are true, if these conditions are true, print a. Else print b. When we should print b if b is greater than c. Else print c. That's all, friends. And this is how we should create Lambda functions, but still no problem. If you want to practice or if you want to explore, there are many examples outside. So you can pick few of the examples and you can try to get more deeper idea about Lambda functions. But this is the idea. This is the idea how to create Lambda functions in Python. Even the same concept is there in Java as well as in C Sharp and many more languages. And these are very important. Just try to understand these, friends. So can you please confirm if you are good with this concept of Lambda functions in the chat box? Meanwhile, I'll try to run this case 4 and see the result here. You know, this is the reference or variable which is pointing to our Lambda function. And we had already a clear discussion. This variable x is used to invoke this Lambda, to call this Lambda, which variable, this x, variable x. For any reference with this Lambda, we use this x. To do anything with the Lambda function, this variable, this reference or this variable x is very much needed. Okay, friends. Of course, it need not to be x. We can give any name to this variable, but we should have a variable which is pointing to the Lambda, and through that variable, we try to call that Lambda function, or we try to manipulate on Lambda functions. Now we should call this Lambda. We use this x, and we pass 3 values as we should find greatest of 3 numbers. You can see here calling this x and then passing 3 values through this reference of Lambda, which is x. Okay, and we are passing 3 values here. So what do we do right now? Let's run this code and see which is the greatest of these 3 values. And we know very well 10,000 is the greatest one, but we want the code to test it and give us the result. So let's do that. Now you can see here. Can you see here? We have here 10,000. I hope this is clear because that is the biggest among these 3, greatest among these 3. So that is the idea, friends. That is idea about finding greatest of 3 numbers using Lambda. But by now you should be very clear with what is Lambda, how to create Lambda, and how to just create that lambda in just a line of code. So all these things should be clear for all of you friends. Okay. Now, next one. Just a minute. Not sure. Yes, we have a recording here. Now, after that, what do we do right now? So these are all few important points about Lambda. Let us try to have a quick idea about these important points. Point one, Lambda internally returns an expression value, and we are not required to write return statement explicitly for Lambda. So like in other functions, if you see here, if we should return a value from a regular function, then we should return a value from such functions. But if it comes to the Lambda, that is not needed. So what is the point here in Lambda? If you want to return any value, here we can see we are returning A, or we are returning B, or we are returning C. But explicitly we are not returning any value using return keyword, like in this regular functions you can see. If it is regular functions, we are using return keyword to return a value. But in Lambda functions, we don't need to explicitly use return keyword to return that value. So implicitly by default, Lambda functions return value. So that is the simple important point to remember. So what is it here? Lambda internally returns an expression value or implicitly returns an expression value, and developer doesn't need to write return statements in Lambda. I hope this should be clear for all of you friends. Understood? That's the idea about one important point about Lambda. Second one, sometimes we can pass a function as an argument to another function. Remember this. This is very important for you. In some cases, we should pass a function as an argument to another function. In such cases, Lambda functions are best choice. So passing a function as parameter instead of passing a regular function, if you pass Lambda, then it is much more simpler. Maybe you can ask an example. What is it? So can you show us few examples where we can pass a function as a parameter to another function? If you can ask this question, then we are going to quickly talk about it. So this filter, this map, this reduce functions accepts a function as a parameter, not a variable or a value as parameter. Now we are going to see such examples where a function takes another function as a parameter or argument. So in such cases, understand this carefully, friends. If you want to pass a function as an argument to another function or a function as a parameter to another function, in such cases, Lambda functions are best choice. Of course, we can pass regular functions as well, but more than regular, Lambdas are much more simpler because they are simple and short. So that's why using Lambdas as a function argument is one of the best choice to the developer. I hope this is clear, friends. Understood now? Now, again, the third thing is filter map reduce functions. Usually they take functions as arguments, and in such cases, passing Lambda as an argument to such functions is the best choice. I hope this is clear. I try to give you a clear heads up about Lambdas here. So about now we had a clear discussion about couple of things about Lambda. What is it? We had a clear idea about return type of Lambda now. The question is simple. Should we return a value from a Lambda function explicitly? What is your answer, friends? Can you please answer in the chat box? Should we return a value from a Lambda function explicitly? Is it needed? Please answer in the chat box. No, thank you. Second thing, again, coming back to the another scenario. So what is the another use of Lambda functions? We can pass a function Lambda as an argument to another functions, right? And one such best scenario is these three functions usually accepts arguments as functions, and Lambda is best choice. in such cases. I hope this is clear. Okay, let us jump to this map, filter and reduce. Let us not stuck here for a long time. But I believe you got a clear picture about Lambda and pros and cons about Lambda. But if you want to implement a very complex logic, so again, still it will be a little confusing if you are going for Lambda. If you're asking what is the disadvantage with Lambda functions is again, as complexity increases, creating Lambdas becomes very difficult. Generally, Lambda is recommended when you have a simple code to implement. But when you are going with a more complex implementation of logic, so lambdas are little confusing, or this becomes much more difficult to implement. Lambdas becomes much difficult to implement. That's all. That is the disadvantage, but still it's okay. We can implement it. So that is the idea, friends. I hope you are good with all this, right? I'm jumping to the next topic. I don't want to stuck here. So let's jump to the next topic, map, filter, and reduce, one of the most popular topics in Python. And you definitely expect a lot of questions in this on these four different topics. If you go and check in interview questions, definitely, or if you attend an interview, most of the interviews who are matured interviewers, what I say, they definitely expect something on this in interviews. This map, lambdas, and then map, filter, and reduce functions. And these are also very much useful in big data implementation. Okay, that is fine. I'm just trying to make you understand the importance of all this. Okay. So now let us talk about map function. What is a map function here? You can see here, right? Map means as the name says, right? It is something which try to iterate on each element of a collection and implement some logic. So that is what map function does here. Okay. But here we are not seeing map. Just a minute, friends. Let's get to the map code. Yeah. So this is the map function. You can see here. So as we are talking about map, what is a map function here? Suppose there is a collection like this, and you can see the description about map function here, friends. If we want to iterate every element in a sequence of data and apply some functionality, then Python is offering a function called map here. What is the meaning of this? You have a collection like this, and you want to iterate each element in this collection. And if you want to apply some logic on these elements, then map by default apply that kind of logic. And here you don't need to write lines and lines of code to implement that. We just need a map function, a map function as well as, and it takes two parameters. One is function as parameter. Second one, sequence means a collection. A collection as parameter. So this is a simple idea. Again, I'm repeating this about map one. What is it? What is a map function here? These are all built-in functions. All these are built-in. You don't need to worry much about this. And what is the functionality or behavior of this map or filter or reduce? We'll talk about map first. When we talk about map, what map function does? This is the syntax of map, which takes two parameters. You can see the first one, it is showing the parameter itself is named as function. It takes function as parameter, not a variable or something. And second thing, it takes sequence. Sequence is nothing but a collection kind of argument. So this is the syntax of map. Now, what is the execution flow of map here? What is the behavior of map? So what it does, it if and here it try to iterate every element in a sequence. Whatever the collection you are passing, it try to iterate that collection and apply some functionality. That functionality is what it might be addition, it might be subtraction, or it might be division, or whatever it is. So that is what the sum functionality. Sum in sense any kind of functionality. And to do that, Python is providing us this map function, friends. I hope this is clear for all of you. So that is the idea. I'm trying to be more clear on this. So I'm just trying to stay here and giving you clarity because these things are little difficult to understand. Okay. It takes time to understand. So I don't want you to have that confusion. So I'm just making it simple for you friends. Clear now? Let us try to implement a simple map program, map function with this use case. It is so simple, of course. See, when you just understand the concept and the description, everything, I don't think we have any difficulty. But if we don't get to that point, then it might be little confusing. So I don't want you to have that. That's why I try to give a clear idea. What is the what is map and what is the behavior of map and what is the syntax of map. But apart from that, other things are known to you. So function thing is clear, sequence thing is clear to you, right? Let us try to go and implement a simple program now. Let us take this example. So here, what do we do? Let me add map use case, a new file, so that we don't get confused. Are you following, friends? So here, map function. I'm just creating like this. So what shall we do now? Now you can see here in this program, we're just creating a simple list of elements here. You can see. And then what we are doing, we are creating a simple function, right? Before you use map function, we need two things. What are those two things? One is we have to prepare a function first. Second, we should have a sequence. So these two are inputs to map function. And if we want to implement to if we want to use a map function, so these two we have to prepare these two things first. Whatever the parameters that we need to pass to map, first we need to create them and keep them ready. That is important. So point one, in the first case, you can see first point, what is this map function takes what? Takes two parameters. What are those two parameters? One is, what is it? Function as argument. First one is function as argument. So we should prepare this, create this function and keep it ready. So that is first one. I hope this is clear. Second, we should create a list as argument. We should create list. Again, sorry, not list, a collection. Maybe let me just add a collection. A collection or data structure. So that is second one we need. That is the parameter to map. So, and we know map function takes these two parameters, a function and collection. So we should create them and keep them ready. So step one, what is that? So we need to find sum of, we are doing a sum. What is that sum? To this x, we are just adding a value. We are just adding an element to this 100. You can see here. So we are creating a simple function first. This is the first argument. We are creating function to pass to map function. Some function. You can create as you like, okay? To pass to map function. So this is fine. Now, what is this sum list is doing? It is a simple operation, very basic operation. There is no confusion at all in this. What we are doing, we are just adding each element we are passing to this function. Each element we are passing to this function sum list or method sum list. And that element we are just adding to 100. What is the output? The output is something like this. I'm just giving you a clear idea so that you don't get confused. So here, what happens? Suppose we are passing these five values to this sum list, not directly, but map will take care of passing those elements. So this is our sequence, our collection, which is which where these elements are passed to this function. I hope this is clear. Now let us try to understand what this function is doing here and what it returns. Simply speaking, this function just simply add that element x to this 100. That element, whatever we are passing to some list, that is just add it to 100. So here let us see. So we are passing 5 values here. So how many values we are passing here, friends? 5 values. But all 5 values are not passed at a time. They are not passed in one go, but these are iterated and these elements are passed one by one. So now for first time this one is passed to this sum list. We don't do that. Map function take care of that. Just keep in mind. We are not doing anything manually. So map is something which does all this. But to use map, we should create these two. What is it? A function where it implements some logic and a collection. These two are important. We have to create them and keep them ready and pass to map function. And I'm trying to give you the internal execution flow of map, how it works. So here, if you see for first time, map try to iterate this list and try to get this one and pass it to this sum list function. And internally, how what happens here? It is a simple 100 plus 1. How much? 101. And that is written. And again, map come to 2 and then try to iterate 2 and pass to this sum function. Now, sum function, what it internally does, it just adds that 2 to this 100 and it returns 1 or 2. And again, in the third case, map function try to extract this, iterate this 3, element 3 and pass it to the sum function. And then 100, what happens in the sum function? Sum just add that 100 to x, it will be 103, friends. And the fourth time it comes to 4 and try to again iterate 4 and pass it to the sum function. And what sum function does internally? Add that x to 100. What is it? Nothing but 100 plus 4 is 104 and 100 plus 5 is 105. So this is what happens internally when we pass these two parameters, a function and a sequence to a map function. What map does internally? So map will try to iterate this sequence one by one, each element one by one, and then pass it to this function and all that result, you can see this is all the result that is returned by this function and all that result is captured. So that is accumulated. Accumulated means that map function, once that result is written by the function, it try to store all those values and then try to return all those values in some form. So this is the execution flow of map, friends. So are you clear here now? So are you following, friends? What is map doing here? Map is a simple function, a special function in Python. What it does, it takes a function as a parameter and a sequence as parameter. It takes two parameters. So if you should work with map function, what is that first you should do? You should prepare two parameters, one a function and then two a sequence, which you want to pass to the function. So we should create these parameters and keep them ready. And now once they are ready, then we should declare map function and pass those parameters to the map. You can see function as first argument and then sequence as second argument. This is the sequence. How map works here? Map iterates on the sequence element by element. Each time it is iterating, one value is copied from here to here and then addition is performed and that return is written back by the function. This function return that result once this addition is done. Okay, all that values are in the same way. What map does, it try to iterate all the subsequent elements and every time it iterates it passes an element to the sum function and that result whatever it is returning, that is accumulated by the map and it preserves all these results in some place. I hope this is clear, right? Finally, once all this iteration is completed, that logic you can see here, every time it iterates an element, this sum is applied and it returns, it gets that result and try to preserve that result. And finally, and that is assigned to some variable, when we print this variable, we can see all that result there that is accumulated by this map function. What map is doing here? Map function is doing couple of actions here. One, it is taking function and a sequence as input. It is iterating that sequence and passing those elements to this function and applying some logic, and this functionality is applied on this sequence. And whatever the result that is written by the function, again, that is accumulated by map. And that when we call that this variable here, now you can see here, this variable will give us that result. All that accumulated result, whatever that is map is returning, if you want to extract that result, then we should use this variable. And if you print it, then we can see that result that is generated by map function. Is this clear? I hope I try to be more clear here without any confusion. Can you please confirm if I made it clear to you or did I confuse you? Can you please confirm over the chat box, friends? Right. How about others? Harish is clear. How about Raja or Sunita or Balaji? How about you, friends? Are you good with this? So this is how map is doing, friends. So finally, if you understand map, filter and reduce is almost similar. Nothing big difference. Again, they take similar kind of parameter. Reduce, I believe, don't take two. We'll see one by one. So map is nothing but what I hope you are clear by now. It just applies a functionality on this on the sequence of elements. Iterate and then iterate them element by element, and finally, whatever result is written by this map, that is accumulated, and we have to print it. Right, let's run this now. You can see here, of course, suppose if you are not doing this conversion to list, what happens? Let us see this now. So what happened here? This is the map function. You can see now. First, you can just create a map function and then pass what a function as parameter. What function we should pass? Here we are creating a sum list. We can pass sum list as a parameter, and then comma a sequence which is nothing but L. So this is fine. Then we should assign it to some variable, and just we are assigning to some variable L1. And this variable acts as a reference to map because these are anonymous functions. We cannot directly access them. So we try to assign these colors to some variable, and then we try to access we will try to have access to those map or filter or reduce functions. Okay. Now if you print this like this without applying a conversion typecasting to list function, what happens? Let us see this now. Right click and then see it is great. So all that what happens here, map function will implement this iteration and then it try to get results of all those addition. That is fine. But all that result what is that is written by this sum function is stored internally in this map object. If your output is like this, you don't need to worry anything. This is also this is valid. You don't have any problem here. If you see your result like this, you don't need to worry or you don't need to get anything. I mean, we don't need to panic on this. So what do we do right now? Just iterate this map. Even map is a kind of object where we can iterate it. It's a kind of collection internally. You try to store elements. What do you do right now? One approach is iterating it for I in L1, and then you can print that whole list of results that is there inside map. So run this now. I definitely can see the output here. You can see here. Are you able to see all that result that is there inside map now? So you can see 101, 102, 103, 104, 105. Means what is the point here? If you don't apply any casting to list or something else, you don't need to worry about it. But what should we do? We have to just simply do an iteration on map to get all that values that are there accumulated inside this map. Accumulated means stored inside the map. Okay, so just iterate that, and then when you print it, you can see all that results that is there inside map after performing expected functionality through map function. I hope this is clear, friends. This is the simple idea. So this is use case one, where if you directly apply map, we get output like this. We get a map object, remember, and that map object, if we iterate, we can see all that results that is there stored inside map. So that is a simple idea. To avoid this, to make this simple, what we are doing. So this is case one. Just let's apply here. This is case one. Case two, we can simplify the same by doing a simple casting. We already have discussed collections, right? So applying as this sequence is a list and internally map what it does, it performs some kind of operation on this sequence, functionality on this sequence. The functionality that is applied on this sequence is nothing but this sum. Once this sum is done on each element, you can see it try to iterates each element and apply some functionality that is nothing but sum here, right? And all that results returned internally, it will be in the form of list. So you can do one small casting here. Just convert this whole map to list so that you don't need to do a quick iteration and still that output can be is visible to you. Of course, even list is a collection. We need to iterate if you want to extract elements from list that we are familiar from collections discussion, right? But that is fine. But if you directly use map, your result is not visible, but they are stored inside map and you can see here. And if you print that map object, it looks like this. You cannot view any result from the map object unless you iterate that map object. But if you want to view your result that is there inside map object, then apply a casting to some of these data structures. Like now, right now, we are converting to list, assuming because our sequence is a list here, right? So what do we do right now? So sorry, I have to do this here. So just apply casting to this map to list now. And then print this. Okay, run this now. Now in the second case, you can see when we converted this map to list, all your output is visible inside list. But if you don't do that at line 11, if you are not converting map to list or to any other type, you can see your output is not visible. It is just accumulated inside map and that is written as a map object. So that is the quick difference between case one, where if you just use map alone, all that result that is accumulated inside map, if you print it, so that is written in the form of what, friends? Just a map object. And if you want to view that result that is present in map object, we should do some iteration on that map. And finally, we get expected output. So we have to follow few more steps to view that result that is there in map function. But if you are just casting it to some required type like list here, then we don't need to iterate it and we can view the result or output that is there inside map object. Of course, even if it is a collection, we need to iterate even in later stages. But at least we can view that output directly. You can see here. So that is difference between using map function directly and applying a casting to a map function. So this is the all about this special function. I hope this is very interesting. You can see here, it's lot. If you try to observe this map function, there are so many interesting things about map. What is it? So you have to have two parameters. We should create them first and make them ready. That is step one, right? So we have already observed and discussed that in detail. Again, if I repeat it, you might get bored. So I don't want to do that. I'm just concluding. Step two, what map does? Iterate on every element of a sequence. Remember, because you need to remember this functionality. And then apply some logic on that. Here we are using sum, so it returns sum. Next time it might be something else. It might be subtraction. It might do that as well. It's not like always map does sum here. Whatever function is that functionality is applied on sequence. It might be sum, it might be subtraction, division, or some other kind of logic that is there, which is implemented in this function. So what map is doing, instead of we iterating the sequence every time, what map does doing that iteration of each element and apply this functionality here. And finally, whatever result is written by this function, all those results are stored inside map object, right? And we use that map object to extract our results and perform whatever implementation or logic processing we need to do. So that's all, friends. This is the idea about altogether about the whole map function. Hope this is clear. Right. So that's all about it. Maybe if you want, you can try another example. Using Lambda, of course. Now we have observed about, we understood about map function. We understood about map by using a regular function. So here we have observed passing a regular function as a parameter to map. But how can we simplify same with Lambda? That is second use case again, another use case. Now we can use the same program as is, but see how simplified, how simple it is if you use Lambda than a regular function. See, this is the example, which is just fine-tuned example of 7. 8 example 8 is a fine-tuned or refined example of example 7. In example 7, we have used a regular function to pass it as a parameter to the map. But in example 8, we are replacing that regular function with a lambda. And if you can see how simple and fine-tuned this example 8 is, right? What we do right now. So let us try to write it ourselves instead of copying and pasting. If you write, we get more clarity. So what do we do right now? Let us rewrite the same code which we have created for map here. But by the time we finish this session, you should be very clear about these methods like map, filter, and reduce. And also, you should have a clear idea about those parameters. And also, you should have a very clear idea about the result that is returned, how it is returned, what is the object that is returned directly, or what if you cast it to some collection. All these things should be very clear to you. So map with the, I'm just writing here, map with lambda to be more clear. Okay. So now let us just, right, I'm asking quick questions. Maybe if possible, please answer in the chat box. If it is a special function like map, it takes how many parameters, friends? It takes 2 parameters, right? What is that? We need to prepare one function which usually provides the logic for us. Second thing, what is second one? Apart from function, we need to also have a sequence. That sequence is nothing but a collection of data. So what map does? Now let us do that now. So first create your sequence or collection. First declare a collection. Here again, I am taking a list here. So that you can create even tuple, I believe. We'll test a few examples with the other collections as well. So, but now what we do, let's create or fine tune the previous example with the lambda. And in this, the step 1, what is that we should do here? First, create a list of values. So that is step 1. How do you create some list 1 equal to X? Here just pass some values 10, 20, and then 30, and then 40, and then 50. You can pass any values of your choice. I'm just passing these. You can try with other values. It's up to you, friends. Then creating a map function. So map of, map takes 2 parameters. If you see, this is a built-in one. It takes 2 parameters. It's not user defined. Map is a built-in function. Excuse me, friends. So now what are those 2 parameters? It takes one function to sequence. Already sequence is ready. I can pass sequence L1 to the map. So you can see passing that sequence L1, which is list. But that logic, we need to pass some logic, that functionality. So did we create or prepare that functionality? We didn't create any functionality. That we are doing with the lambda directly. So what do we do? How do you create that function here? See here, we don't need to create a separate function if it is lambda. We can directly pass lambda as a parameter to this function map, lambda space. So what is that we need to do? How many parameters will it take in this case? If you are fine tuning this code, that lambda function just needs one argument. So some x, if not x, you can put y or a or b. Variable names are your choice. Colon. What is it we are doing? Every time map iterates one element from L1, this list. It has to be incremented by 100. That is what we are doing. Each element of this list is incremented by 100. And again, those results are again replaced in this list itself. Whatever the result we get, suppose for 10, 10 is incremented by 100, we get 110. That is again replaced in place of 10 here. Again, 20 is incremented by 100, and that 120 is again replaced into this element itself. So that is what map does. It try to iterate each element of this list and perform some action on this list, and again replace the result that is acquired into this list itself. So that is what function, that is what map does here. What map does? Sorry, friends. I think there is a slight cold caught up here. Okay. Means what? It takes some data structure, iterate it, do some functionality. Again, just try to update that result with that functionality. I hope this is clear. Whatever the result that function is returning, that is updated into this particular data structure. That's what map does, right? So what map is doing? Map is trying to update each element in this sequence. So it iterates element by element and try to update that result that is there coming from that functionality, and that is updated into this particular sequence or data structure. Again, just keep in mind, friends. Now we need to what we are doing. We need to apply some functionality here. So we are creating with Lambda, and here what we are doing. So we just created, and we want to increment each element of this list or sequence by 100. So what you do 100 plus x. So that's all. So see the difference between the previous program and this program. If it is Lambda, you don't even feel like you are passing a function here. It just fit into this very simply, very easily. Fit into this map function very easily without any big this thing here. Understood, friends? Now, but if you just declare like this, do you think we can can we get this output from map here? So of course, this will try to execute. Map function gets executed, and that functionality is applied on this list. All that is fine. But the problem here is what, friends? We cannot have access to that result. So what we do? We should assign this map color to some variable here. You can say some result equal to. Now this is acting as a reference to this map object. Now what shall we do now? We have to print it directly. If you want, you can print it. So the result. So if you print it, what happens in this case? You know, right? And then print it. You can see it returns map object, right? So, but we don't want it to be like that. Of course, if it returns map object, do we have a problem? No. We just need to iterate this variable and get that result element by element. That's all. If we apply that iterator for, automatically we can view that result that is accumulated into this map. Okay, map object, right? So what do you do right now? Simply you can apply a casting to the list because this case is discussed. So you know what to do now. So to avoid further delay, I'm just directly applying a casting of map to list here and returning here. Just right click and run this. Now you can see you can view all that functionality applied to each element of that sequence here. You can see 110, 120, 130, 140, 150. So this is the behavior of map. What map does? I'm just concluding map here. I hope this is clear for all of you, right, friends? Before I conclude, I believe you are very clear. So this is one approach of implementing map function by using a regular by creating a regular function. But the same program we are rewriting with Lambda, and if we just use Lambda, you can see how fine tuned this is and how simple is this to observe here. Which one do you think is much more easier to observe? This case one or this approach one or approach two? Which looks more simplified? Can you please answer in the chat box, friends? Case two, definitely. Thank you, Sunita. Right. I hope. I made you clear with this because this is something which if you go and observe some, I know, just you try to go through any other different sources, right? It's very simple topic, but people get confused easily if you are not clear on this, right? If you don't believe me, you can just give a try. You can go through some other existing examples outside, then you come to that conclusion. But now you don't have such problem now. That is my gut feeling. But it's okay. Still, if you have any confusion, still if you are not clear, you just try to raise that point, friends. We'll have a very deeper discussion. No problem. So this is the idea, right? So got clarity, I hope you already answered. You are clear. I don't want to again. So let us do one more small functionality with map. What is it? Okay. And this is a question saying that what is it? Map. A map function can be applied on multiple lists, multiple sequences. It's not just one sequence. If you want, you can apply on multiple sequences or multiple data structures at a time. But But the point is, see, you can apply map on multiple sequence or multiple data structures or multiple lists or multiple tuple will test it now. But make sure all those lists have same length. Suppose you have two lists here. This has 4, this has 3. It won't work. So you want to apply a functionality on two different data structures at a time, two similar data structures at a time. Then what then make sure that length of those two data structures or sequences are same here. Sequence is nothing but collection. Collection is nothing but data structure. You can call with any names. All are same. Just keep in mind, friends. I hope this is clear for all of you, friends, right? So this is a simple example. We'll test all this one by one. But keep in mind, if you are really familiar with one of these special functions, then you are almost good with filter and reduce. Just a slight change in the behavior, that's all, functionality. Other than that, the all syntaxes look same here. You can see here reduce takes two parameters, function and sequence. Of course, I am jumping to another discussion. Let's stay here. We'll finish this and go to that topic. So this is map here. Right, we'll come back to this example. Let us see a small example. Let us create a tuple and see if it works or not. Okay, this is step 1 and this is step 2. Here, function and map both are created hand in hand, we call. Hand in hand means both in one go. We are not creating a function first and preparing function first and then passing to this map function, but both are created hand in hand. Both map function and then this parameter to map are created instantly. You can see here they both go hand in hand. So that's what happens when we use Lambda. Okay, I hope this is clear. We ran this example, we saw the output. Now we are very clear. But understand the functionality of map. What is it? Map iterates each element in a sequence and try to update it with some functionality. So that's what map does here. So each element of your sequence get impacted when you are using a map function here with some kind of logic or functionality. Whatever functionality you are passing, with that functionality, each of these elements in the sequence get updated. Just remember, friends, just keep this in mind. So that is the idea. Okay, fine. Now, what is it now? Is there any other examples? Well, let's get back to map and pick them. So these are all filter examples. I don't want filter now, but we want map. So map example, this is fine. We did it. So this is another example. Let us take this example. This is like doing square of numbers. Let's do it ourselves. Let's not copy and paste so that you get more clarity. So we are just creating another program with the map function. So this is use case 2. Let's implement here itself. We don't need to create a separate file because it is a simple one. What is that we are doing? This time we are creating a functionality. What is that functionality? Square of each element of a sequence. Square of each element of a sequence. This is the one we are doing now, right? Now, sequence. Now, what do we do? What is this map needs? Map or any of these special function needs two parameters. What is it? A function and a sequence. First, prepare sequence because we can create function and map together, okay, in one go. So, sequence. So now what do you do right now? First, declare a list with some values, some 1, 2, 3, 4, 5. Now we should get the output like this. Our output has to, this is the input. Our input looks like this. Let me be more clear so that you don't get confused. 1, 2, 3, 4, 5. So this is our input and output should look like this. What is our output? Our output should be like this. Of course, we can do that in different ways. Even without map, we do that. Something like 1, 4, 9, some 16 and 25. So square of each number should happen and those values again should get replaced into the same list itself. So for that, best option is choose map. Okay. Now what do you do? Apply map and then we need to pass a function. Is any function ready to pass to this map? Did we prepare any function to pass map? When lambda is there, why do we need other functions? We can just cook it instantly. What we can do? We can cook or prepare it instantly. So what do you do right now? Lambda space. What do we need? How many parameters to iterate each element? One parameter is enough. And then because this list has just only a param, we are iterating each value at a time. So to this function, we can just declare one parameter. And then what is the functionality? We need square of two numbers. See, we just applied a logic here, x into x. This gives square of each element. So that is passing to the lambda function. Comma, again, we should pass sequence, which is nothing but this one. So this is what we should do. First, we should create a function and then pass it to the map function. You can see map takes a function as parameter. That's you can observe that. And to that, we should pass sequence of elements. And this function, whatever we are passing here, that is applied on the sequence element by element. And whatever the result that is written, again, that is replaced into the same list. And at the end, that is stored into this map as a result. And if we iterate it, we can view that result. Or if you apply any conversion, we can directly see the output. So that is the idea. Now, what we do now, if we just leave it like this, can we have any access to this map? No, right? So we should assign this color map color to some variable here. So put some result equal to some squares equal to map. Now, what do? We need to do. If you print it like this, it just returns a map object. We are very clear. So apply a small casting to this map. And then what? Just try to print it here. Okay. So that is the idea. So finally, print squares. So if you print squares, so maybe if you want, you can add the format method. The output is and then dot format and then you can print what squares. So this is the idea. So this is how we can implement a simple map function by and what is the requirement here? We want to iterate a sequence and then update each element of the sequence with a square of that element. So that is what we are doing here. Right click and then run this and now you can see this is the input and are we getting the expected output? You can see here. And is this use case clear to for all of you friends? So this is a simple idea about what is this working with the map function. By now you should be clear on this map functions. Can I get an S from all of you or did I is there any confusion friends? Thank you. Seems like you got the point of this, right? So this is a quick idea about map functions. We have few more. I think filter and reduce. I thought we can finish all this today, but this topic went little deeper and we took enough time to understand this clearly. So what we do is we'll take one more example of map. Okay. So that you get a clear idea. So finally, what is the execution flow of map? So finally, what do you understand? As per a definition here, it iterate every element in a sequence of data and apply some functionality, right? And then that result is returned again, updated into the same sequence. Keep in mind, friends. Again, that result, what is that is produced, is updated into the same sequence. If you look at the output, you can see here, right? So this is the idea. So now, why don't we try one more quick example? Do you want to try another quick example? So this one. So let us try handling multiple, iterating multiple lists or processing multiple lists with the map function. Right. Let's just see here. We are just trying to again implement a map function, but here what we are doing, we are just trying to use multiple data structures. We are not just implementing with one sequence, but this time we are using two sequence, right? So what we are doing, let us anyhow just go here. So what do we do? Let us create it from the scratch to get a better view of understanding of that scenario. So map with the what, friends? Multiple sequence. So now what do we do? Take as usual, we are just implementing this use case with multiple sequences. Unlike in the previous examples, we are not just using one sequence, but we are using multiple sequences. Okay, so here declaring first take one sequence. What is that sequence? 1, 2, 3, 4, 5. Make sure the length of these data structures are same. Again, some 10, 20, 30, 40, 50. Now, what do you do right now? Simple, take a map and then lambda, our friend lambda, and then xy2 parameters, colon. Either you can do one thing, right? So we can directly apply what we can do, we can try apply a logic on both of these elements in one go. You can see here, we can say x plus y here. Something like this, comma, means what we are doing? We are trying to add element of L1 and L2. 1 plus 10, 2 plus 20, 3 plus 30, 4 plus 40, 5 plus 50. And then here, we need to pass two sequence here, L1, comma, L2. Now, every time this map iterates, it picks one value from L1 and L2, and those values are passed to lambda here. And then from lambda, this function, this logic is applied, and it try to replace into this list here, update any one of these lists. We'll see which list get. So now apply a conversion, some list of map of this thing, and then assign this result to some, what is it? Some result equal to like this, and then print it. Now run this now and see if it is working. Now you can see here 11, 22, 33, 44, 55. So is this clear now? So this is what simply trying to iterate two different sequence and then add those elements from those two sequences. And again, that result is updated into, I believe, one of these two sequence. Okay, so that is the quick idea, friends. Understood now? Internally, I mean, not explicitly, not here. Suppose let us just print your results first. First, your not results, your inputs first. Print off L1. This is one. Second one, L2. Okay. So that is the input, and finally, this is the output we get here. You can see here. And now, if you see, this is why I printed here. If you see here, 1, 2, 3, 4, 5, 10, 20, 30, 40, 50. Yes, these two are input sequences. And finally, we got output sequence here, right? So what is happening here? Internally, it uses these two lists. Temporarily, it will create one dummy sequence and try to update these elements, the result of these elements. And finally, that is written here. Now, if you print it, you can see the output. Excuse me, friends. This is the idea. Hope this is clear about what is it, friends. Iterating on multiple sequence with map function. Clear? Run it and you can see. Next one. So one quick use case. What is that use case? Copy this now. And paste it here. Let us see if this map works on a tuple as well. I just want to see if it works on a tuple. I think I tested this sometime back, but would like to test it again. Case 2, using a tuple not as a list, as a argument here to map function. So this time L1 is a tuple and we are passing a tuple as an argument, but still it is a sequence. Tuple is a sequence, list is a sequence, both are sequences. Okay. So let us try to run this and see if it works or not, friends. It's working pretty fine, I believe. You can see here 110, 120. Even you can pass sequence as tuple as well. I hope this is clear for you. So this is another important observation. So when you are working with map functions, it is not just list always we should pass as sequence. Even you can pass tuple as sequence. It's up to you which one you want to pass, but you are clear on these things, right? So what did we cover? We had a very detailed discussion in today's session about many things. What is it? One is understanding lambda functions. That is one thing. Second thing is understanding about map functions. Third thing, how to create map functions by using a regular function as parameter. Fourth thing, how to create a map function by using lambda as a parameter. And fifth one, we have seen how to create a map function. Map function with what, friends? By taking multiple sequences as input to map function, or multiple sequences as parameters to map function. This one, right? We had discussed all these use cases. So this is a simple idea about map function. In tomorrow's session, we'll try to cover reduce and filter. And even they are very much useful functions, but I don't think we take much time for filter and reduce, because already you are very clear on this execution, I mean on this map thing. So that helps you to understand filter and reduce quickly. You don't need much time, friends. I hope this is clear for all of you. We'll stop this session here. If you have any questions, I'll try to answer them. Else we'll close the session. Are you good, right? Okay, friends, then we'll just close this. We'll connect back tomorrow and we'll close those remaining things and close functions topic and jump to the next topic. Thanks to everyone.